Hi students, I am your chemistry miss. Today we are going to see the lesson 1, continuation for the lesson 1. Today we are going to see the topic oxidation number. Okay, so first we are going to see the what is meant by oxidation. Yesterday we studied what is oxidation. Oxidation means addition of oxygen, removal of carbon dioxide. But in the terms of oxidation, electronic concept, what is oxidation? Loss of electron. So what is meant by reduction is the gain of electron. Okay, so what is meant by here we are going to see the what is meant by oxidation number. Oxidation number is the charge assigned to an atom of a molecule or of an atom. So oxidation number, so here that is oxidation number is the charge assigned of an atom. Say for example here, so that is Na plus, so that is Na plus ion. This is oxidation state of sodium, so that is plus 1, that is understand, that is plus 1, that is called as oxidation number. Suppose here example Fe2 plus. What is Fe2 plus? Here the 2 plus is the charge, so this is the oxidation number of ion. Okay, so this is called as oxidation number. So what is meant by oxidation? It is the charge assigned of an atom. So first we are going to understand what are the condition applied. First one is for element in the, that is elementary state or gases in their elementary state, that is 0. So what is the meaning for that? So for a single atom, say for example here, that is copper ion, so then nickel, then cobalt, so many example, that is individual element, the atom the oxidation number is always 0. Another one for gaseous molecule, hydrogen, nitrogen, oxygen, fluorine, so in this condition the oxidation number is 0. This is the first one. Second one, for hydrogen is always plus 1 oxidation. First your mind in hydrogen, wherever the hydrogen is coming, the oxidation state is always plus 1. Okay, so the hydrogen is always plus 1, except, that is the exception, that is the metal hydride. What is meant by metal hydride? That is metal. Calcium is the metal, sodium is the metal combined with hydrogen. Calcium hydride. So sodium hydrate. In this condition, the oxidation number is -1. That is, you understand that hydrogen, for hydrogen is always the oxidation number is +1. What is meant by oxidation? The charge is assigned for an atom, that is called as oxidation, right? That is calcium hydride, sodium hydride. In metal hydride, the oxidation number is -1. So next one is for oxygen. Next one is oxygen. In oxygen, oxidation number is -2. So that is in oxidation, the oxygen oxidation number is -2. Another one is in all compound except OF2. So OF2 is +2. Then hydrogen peroxide -1. Then sodium peroxide is also oxygen. Oxidation number is -1. So this is the exceptional one. So always -2. Oxygen oxidation number is -2. Next one is in fluorine. Fluorine is always oxidation number is -1. So that is the another one. Fluorine is always the oxidation number is -1. Then again the alkali metal and alkali earth metal. So what is in the periodic table? The first group element is the oxidation number is +1. So second group element, the oxidation number is +2. So what are the element present in the first group? Sodium, potassium, rubidium, cesium. The first group element. So what are the first group elements? Sodium, potassium, rubidium, cesium. So these are the sodium, potassium, rubidium, cesium. So these elements, the oxidation number is +1. For the second group calcium, magnesium. So these are in this metal, the atomic number, the oxidation number is +2. Okay, so another one, it is the algebraic sum. What is meant by oxidation number? Is the algebraic sum of the oxidation number of all the atom in the molecule. So what is the meaning for that? Suppose this is AB is a molecule, right? So that is, you are adding that oxidation number to oxidation number. Here no charges is not there, so that is equal to 0. Again AB2 means the water, that is you are going to understand, that is B2. So here that is AB2. So here 2 molecule, 2 multiply that the B molecule, your oxidation number equal to 0. This is the another one. First you are going to calculate the oxidation number. So you can easily understand how to calculate the oxidation number. Example 1. Okay, example 1. First you have to find out carbon dioxide. Oxidation state of carbon dioxide in the compound is carbon. Okay, I am underlining that one. So the compound is carbon. How to calculate? Let us consider this is the consider your carbon is X. Carbon is equal to X, right? So we are going to find out the oxidation state of this carbon. So that is you are assume it is X. Oxygen, what is told? Oxygen is always oxidation number of oxygen. Oxidation number of oxygen. What is the oxidation number of oxygen? Is always -2. So that is the reason I am telling that the for oxygen is -2 in all compounds. So that is here. Oxidation number of oxygen is always -2. So now you substitute all that values here. How to calculate? Carbon is assumed. This is the carbon dioxide, right? So carbon is assumed X, right? So oxygen, how many oxygen is there? 2 oxygen is there. So that is 2 multiplied -2, right? So that is oxygen oxidation number is -2. So here X plus 2 into -2 equal to 0 because here no charges is not there. Here in the charge may illa. So that is X 2 minus 2 equal to 0. So X minus 4 equal to 0. X is equal to plus 4. This is the oxidation state of carbon. Carbon oxidation state is plus 4. This is the simple calculation. So first one is carbon dioxide. First you are consider முதல்ல என்ன அசைன் பண்றோம் கார்பனுக்கு X ன்னு நம்ம அசைன் பண்ணிக்கிறோம் எதுக்குன்னா you are going to find out the oxidation state of this carbon. So that is you can assign that is X. Okay, oxidation number of oxygen is always -2. So now you substitute. How to substitute? Carbon is X. So that is you substitute 2 molecule of oxygen is here. That is 2 minus 2 equal to here no charges is not there. So that is equal to 0. X minus 4 equal to 0. X is equal to plus 4. Okay, this is one example. Next example, that is sulfuric acid. Next I am doing the next example. Sulfuric acid, that is H2SO4. Second example, H2SO4. You are find out the oxidation number of sulfur, right? So what is the first step? Let us consider S is equal to Ex, right? This is the first step. What is the second step? Hydrogen oxidation number. I am writing this short one. Oxidation number of hydrogen is +1, right? Oxygen oxidation number equal to, what is the oxidation number? -2. That is the previous problem is also we see that one, right? So that is -2. Now you substitute all that values in the sulfuric acid. Hydrogen, how many hydrogen is there? 2 hydrogen. 2 into +1, right? Plus. Okay, so no, that is only you are adding that all that value. Then what is the sulfur? Sulfur only you are going to find out. That is we assume that is X, right? So next one is oxygen. Oxygen, what is that oxidation number of oxygen is -2. How many oxygen is there? 4 oxygen. So 4 into -2. Here no charges is not there. That is equal to 0. Okay, so that is 2 plus X minus 8 equal to 0. Okay, so that is X minus 6 equal to 0. X is equal to plus 6. Okay, so this is the oxidation number of, what is oxidation number of sulfur? Okay, this is the another calculation. First என்ன பண்ணிருக்கோம்? Let us assume S is equal to X. So oxidation number of hydrogen is always +1. Oxygen is always -2. Now you substitute. How it will substitute? 2 into +1. So 2 molecule of hydrogen is there. Hydrogen number is +1. 2 into +1. Then X 4 into -2. Oxidation number 4 molecule oxygen is there. So 4 minus 2. Now you substitute all that values. You can find out X equal to +6. Next another one. Cr2O7 2 minus. You have to find out oxidation number of chromium. So how to calculate the oxidation number? how to calculate the oxidation number in Cr2. What is the first step? Chromium is equal to X, right? What is the chromium is equal to X? Then how many X is there? So oxygen is always minus 2, right? Oxygen is always minus 2. How to find out? So how many chromium is there? 2X, right? 2 into 2 molecule of chromium is there. I am writing 2X plus how many molecule of oxygen is there? That is 7 molecule. 7 minus 2 equal to, here 2 minus charge is there, equal to minus 2. Don't forget that. That is, the charge will be equal to that charge, right? So now you can calculate 2x minus 14 equal to minus 2. 2x equal to, that is plus 12, right? Minus 14 is come that side, that is plus 14. 14 minus 2, that is plus 2. X is equal to plus 12 by 2. X is equal to plus 6. Okay. So this is the oxidation number of chromium. Okay. So this is the calculation. How to calculate? Chromium is assigned X. How many molecule of chromium is there? 2 molecule of chromium. So that is 2X. Right here 2X. 7 molecule of oxygen is there. Oxidation number of oxygen is minus 2. Equal to, here charge 2 minus is there, minus 2. So here that is, now substitute all that values here. That is X is equal to plus 6. Okay. So this is the another. Okay. So next one. So next sum is CH2F2. Okay. So next one. Third, fourth one. So that is CH2F2. You have to find out this carbon. Okay. So I already told what is the oxidation. So that number you are considered that X, right? So carbon is equal to X, right? Carbon is equal to X. Next step, what is the hydrogen oxidation state? That is plus 1. What is the fluorine oxidation state? Fluorine is always minus 1. First you mind it. Fluorine is always minus 1. Okay. So now you substitute that one. Carbon, what is the carbon? That is X. What is the hydrogen? Hydrogen, how many hydrogen is there? So 2 molecule of hydrogen. So that is 2. What is the fluorine? 2 molecule of hydrogen is there. 2 into 1. What is the fluorine is? 2 into minus 1 equal to, here no charges is not there, that is equal to 0. So here X plus 2 minus 2 equal to 0. Okay, so what is that oxidation state? So X 0 equal to X minus 0 equal to 0. So X is equal to 0. Okay, so this is the oxidation state. In the CH2F2, the carbon oxidation state is 0. That is 0 oxidation state in CH2F2. Okay, so this is the another one. So next one, SO2. So another one example, SO2. What is SO2? SO2 in sulfur. Okay, S is equal to X. Oxygen we already told, that is minus 2. Now you substitute X minus, that is 2 molecule of oxygen is there, 2 minus 2. Here no charges is not there. X minus 4 equal to 0. X is equal to plus 4. So this is the plus 4 oxidation state. So this is the another one. Here that is sulfur is equal to X. Oxygen is always minus 2. Now you substitute that SO2. So X into 2 minus 2 equal to 0. X minus 4 equal to 0. X is equal to plus 4. The oxidation state of sulfur is plus 2. So this is another important one. So this is the oxidation number. This question is repeatedly asking in all the exam. So this is the chromium. So here the charge will be given, that is 2 minus. Okay, so this is the another one. I will give one example apart from book. That is, suppose more than 3 is there means, so how to calculate HNO3. Okay, so you have to find out the nitrogen. So how to calculate nitrogen? So hydrogen is always plus 1. Nitrogen, it is assumed that is X. Oxygen is minus 2. Now you substitute all that values. 1 plus nitrogen is X plus oxygen. How much oxygen? So that is 3 minus 2. Okay, equal to 0. Here no charges is not there. So that is 1 plus x minus 6 equal to 0. X minus 5 equal to 0. What is the answer? X is equal to plus 5. Okay, so this is the another one. Okay, so this is the another one example, HNO3. Okay, so this is the example of all the calculate the oxidation number. Okay, clearly you understand this basic one. Repeatedly you watching that video, you can easily understand. So which number you are going to find out the oxidation number, that element is assumed as X. Okay, oxygen is always, oxidation number is always -1. For fluorine, hydrogen is always +1. Okay, you substitute all that value, you can find out that one. This one is completely different. The charge is already given, so that is equal to that charge. Okay, so that is you have to find out. This is the another one. So how to calculate this one? That is +6. This is the important question, repeatedly asking the oxidation number calculation. The charge will be given. So here no charges is not there, mean that is equal to 0. This is the another one. So here that is the 0. Oxidation number is 0. Here also another one. In water, so hydrogen is oxygen. Then hydrogen peroxide. So I already told hydrogen peroxide and superoxide. This is the another one. Sometimes this will coming as a fraction number. That is in superoxide. What is mean by superoxide? This is the another one. In superoxide, for example, superoxide, right? Superoxide, example is KO2. So this is the oxidation number of potassium. You have to find out the oxidation number of oxygen. Oxygen by oxidation number. So that is, you have to find out that molecule. Potassium is always +1. Okay, oxygen you have to find out. Okay, so how to 2 into x equal to 0. 2x is equal to -1. X is equal to -1/2. So what is the oxidation state in this superoxide? Superoxide means that is 2 oxygen is there. So superoxide, what is the oxidation state? Is the fraction number. So oxidation number may be fraction will also be coming. Okay, so this is another one. Another one, oxygen difluoride. So example, difluoride, OF2. Okay, what is the oxidation state? You have to find out the oxidation state of oxygen. So I already told oxygen is always -2. Some exception is there. So here in this exception, this is we assumed X. Fluorine is always -1. So that is 2 minus 1. Okay, equal to 0. X minus 2 equal to 0. X is equal to +2. Okay, so this is in this OF2, that is oxygen difluoride. In this OF2, the oxygen oxidation number is +2. In this superoxide, oxygen oxidation number is -1/2. Okay, that is the oxidation number may be fraction, whole number, and the 0 will also be possible for the oxidation number. Okay, so this is the calculation of this oxidation number. This is the important topic. This calculation of oxidation number is next we are going to balancing the equation. That is also very important one. How to redox reaction in terms of oxidation number. So how to calculate the redox reaction in terms of oxidation number. First one is, what is mean by redox reaction? Okay. Okay, so next one, redox reaction in terms of oxidation number. So this is one example, potassium permanganate and react with ions ferrous sulfate and react with sulfuric acid to give potassium sulfate, manganese sulfate and the ferrous sulfate, ferric sulfate. Ferrous sulfate is converted into ferric sulfate, then potassium permanganate is converted into manganese sulfate. Okay, so here both, what is mean by redox reaction? What is mean by redox reaction? Both redox reaction. What is redox reaction? Both oxidation and reduction will takes place. Both oxidation and reduction takes place in same equation. In same equation. Okay, so this is one equation I am already given. So how to calculate that one? So how to calculate, that is KMnO4 ferrous sulfate. How to calculate the oxidation number of Mn? So how to calculate? This is the calculation of oxidation number of Mn. How to calculate? Potassium is, this is you already told, no, potassium is +1, manganese X, oxygen is how much? Oxygen -2 into 4, so that is -8 equal to 0. So X -7 equal to 0, X is equal to +7. Okay, so this +7 will be, I am writing here, that is +7, right? So here that is the same one, manganese sulfate. Manganese sulfate here, the sulfate is always -2. Now first you understand that sulfate, that not we are seeing that individual one, the sulfate is -2. So how to calculate? X -2 equal to 0. The sulfate I told SO4 equal to -2, right? X is -2 equal to 0, X is equal to +2. So I am writing here that is the +2. So here that is +7 number, that is the oxidation state of manganese is +7 will be reduced to how much? So that is +2. So that is the oxidation number is decreases. What will happen? That is reduction takes place. So the substance will be reduced means it is good, a powerful oxidizing agent. The substance will be reduced. So that is reduction takes place. So it is a powerful oxidizing agent. Okay, so it is a controversy one. Okay, first you understand that. So first, because the KMnO4 is reduced to Mn +7 oxidation is reduced to +2 oxidation number. So that is reduction will be takes place because the oxidation number decreases. The reduction will takes place in that equation. So that the reagent is act as an oxidizing agent. So now coming to the next one. So that is reduction, the same equation, reduction will be takes place. The same equation, oxidation will also takes place. What is that one? That is ferrous sulfate is converted into ferric sulfate. So here that is ferric sulfate. How to calculate? What is the oxidation number? So we have to find out the ferrous sulfate. X sulfate, as I already told, that is -2 equal to 0. X is equal to +2. Okay. So the oxidation state is +2, right? Okay, this is one correct. So next one is here. Ferrous sulfate. So Fe2SO4 thrice. So Fe2. So that is 2x. How many molecule is there? 3 molecules. So that is 3 minus 2, right? Plus 3 minus 2 equal to 0. So what is that answer? 2x minus 6 equal to 0. 2s equal to 6. X is equal to 3. Okay, so that is the +3 oxidation here, that is the +3. So what is the conclusion here? The ferrous sulfate +2 oxidation number increases to how many oxidation number? +3 oxidation number. How many electron increases? So that is increases the oxidation number. So that is the reason oxidation takes place. The oxidation takes place means the ferrous sulfate is a powerful reducing agent. Okay, it is a powerful reducing agent. Because the reduction oxidation will be takes place, so it act as a reducing agent. So this is the both the oxidation reduction will takes place in the same reaction, mean that is called as redox reaction. Okay, simple thing, again you can calculate. This is the oxidation number calculation. Oxidation number calculation same for all that one. Potassium is +1. The manganese is X in எடுத்திருக்கிறோம். So oxygen is -2, -8 equal to 0, X equal to +7. The +7 is reduced to +2. So that is 5 electron will be reduced. So that is reduction takes place. So it is a powerful oxidizing agent. The ferrous sulfate is also, that is oxidation number increases, oxidation takes place. So that is +2 is increases +3. So it is a powerful reducing agent. So both the oxidation reduction will be takes place mean it is called as, it is a redox reaction. So next we are going to see the types of redox reaction. Types of redox reaction. What is the types of redox reaction? Next we are going to see what are the types of redox reaction. First one is what is meant by types of redox reaction. First type is combination reaction. What is meant by combination reaction? Two substances combine to form a single molecule or a compound. Single compound is called as combination reaction. What is combination reaction? two single molecule combined to form a molecule compound, that is called as combination. So here that is carbon. For an element, the single element, the oxidation number is 0. So that is, first we see the oxidation number, right? The carbon oxidation number is 0. Oxygen is oxidation number is 0, right? The oxidation number will be increases to here. What is the oxidation number of carbon dioxide? What is the oxidation number of carbon dioxide? Carbon. So carbon we assume X minus 4. X is equal to plus 4, right? So that is, I am writing here plus 4. So here the oxygen is minus 2. So here oxygen oxidation number is 0. It will oxidation number is minus 2. So that is, both oxidation reduction takes place in this same reaction, that is called as combination reaction. This question is asked for last year board exam. So last year, previous year board exam, what is meant by combination reaction? That is important one. What is meant by combination reaction? The single two substances to combine to form a single compound, that is called as combination reaction. Everyone, you can write the example, right? Where with the example only you can write the types. Okay, so this is the first one. Second one, decomposition reaction. What is mean by decompose? So that is destroy. So destroy, decomposed agi, divided into two compounds. So that is called as decomposition reaction. Compound break into two or more compounds. These are the opposite to combination reaction. What is mean by combination reaction? Two molecules combine together to form a single molecule, single compound. But here one molecule is dissociate into two molecules. That is called as decomposition. Decomposition என்னன்னா பிரியிறது. So ரெண்டா பிரிஞ்சு போறது, ரெண்டா மூணா இல்ல நாலு. So that is the decomposition, that is potassium chloride, right? So here how to calculate the oxidation number of chlorine? Chlorine, that is potassium. What is the oxidation number of potassium? That is plus 1, right? Potassium plus 1. Chlorine we assume that is X, right? Oxygen is minus 2 into 3 minus 6. What is the charge is equal to 6 equal to 0. X is equal to minus 5 equal to 0. X is equal to plus 5. That is the charge I am writing here. That is chlorine charge is plus 5, right? Plus 5. Here that is Cl. What is the potassium? What is the charge of the Cl? Potassium is plus 1. X plus 1. So how to calculate? Potassium is plus 1. Chlorine is X equal to X is equal to minus 1. So that is writing here, that is minus 1. That is plus 5 will be reduced into minus 1. So here the chlorine oxidation number is plus 5. It will be reduced to minus 1. So the oxidation number will be reduced to, that is called as reduction. So here that is oxygen is minus 2. The oxygen molecule, the oxidation number is 0. That is the first we already see that. Okay, so that is oxygen oxidation number is 0. So this is called as oxidation. Okay, so this is the decomposition reaction, both oxidation reduction in the decomposition. Okay, next one is displacement reaction. What is meant by displacement reaction? The ion and atom is replacement by another element. So that is the metal or non-metal. The atoms are replaced by the one of the other element. That is called as displacement reaction. So here that is what a metal displacement reaction. What is metal displacement reaction? Here copper sulfate is a metal. Copper sulfate is a metal, and the zinc is also metal. The zinc metal is replaced by this copper. Okay, so here that is the zinc is replaced by this copper. Okay, so that is the displacement. Displacement na இந்த இடத்துல இருந்து அந்த இடத்துக்கு மூவ் ஆகி போய்க்கிறது. So that is copper metal will be replaced. Okay, so here the charge of this already I told. What is the charge of SO4? That is SO4 is minus 2. So SO4 minus 2 means X is equal to plus 2, right? The plus 2 is reduced into copper. The whole atom, the single element, the oxidation number will be 0. But here that is zinc is also 0. 0 will be increases into zinc sulfate. The sulfate I already told, the sulfate oxidation number is minus 2. X minus 2 equal to 0, X is equal to plus 2. So that is I am writing here, that is plus 2. 0 will be increased, oxidation number will be increased. So that is oxidation. Here copper sulfate plus 2 is will be reduced into 0. So that is the another example, metal displacement. During the electrolytic reaction, the zinc will be replaced by this copper. So copper will be regenerate. Okay, so this is the another one. The same method for the non-metal. So here metal react with non-metal. That is here, that is metal metal. Copper sulfate is also metal. Here is zinc also metal. But here that is one metal. This is one non-metal. So what is the oxidation state of the single atom? That is 0. So here zinc chloride. Zinc is assumed that X, oxygen is -2 equal to 0. Oxygen oxidation number is -1. 2 molecule oxygen chlorine is there. So that is 2 minus 1. So how to write? X minus 2 into -1, right? X plus 2. So I am writing here, that is the reason X minus 2 equal to 0. X is equal to plus 2. So that is the reason writing here, that is plus 2, right? So here that is hydrogen, whole number, the single atom molecule, oxidation number will be 0. So that is here, that is reduction will be takes place. So here H plus ion will be reduced to hydrogen. So here the oxidation number of chlorine is -1, hydrogen is +1. So that is the +1 oxidation number will be reduced into 0. So that is reduction will be takes place. Both oxidation reduction takes place in the non-metal displacement. Okay, so this is the another one. So these are the types of the redox reaction. This is also very important. Next another one, two more oxidation types of redox reaction will be there. So we see the next video. Okay, thank you children. We see the next video.